Okay, welcome everyone. So today our agenda would be on performing the connection design of some of the components of the pre-engineered building in RAM connection. Now most of you have come across the modeling of the pre-engineered building in several YouTube videos. In fact, we also had discussed a little bit of the connection types in the pre-engineered building, but we never discussed explicitly on the different connection possibilities that can be done in the RAM connection for the PEB structure. So today we will just walk you through to a few of the important connections that exist in most of the PEB building structure, and we will show you what are those connections and how RAM connection handle those connection templates. So I have already opened a PEB structure. Now let me show you the rendered view of this. So here you can see I have already modeled this PEB structure. Now you can see that the column and the slope beams are well flushed. You can see that there is no gap at the junction. In general, if you model the PEB structure, there used to be some gap. But this time you can't see any gap. It is just like the real life PEB structure representation. That's because we have modeled this PEB alignment, this PEB members in the physical modeler interface, where we can define the link and the connection where the column and the slope beam are to be established. So for example, if you want to establish the link through its outer flange, then you can define. If you want to establish the link through its centroid, then also you can define there. By default, in the Norman analytical interface, all the connections are through its shear center. So in physical modeler interface, you can have the choice to define the exact location through which the connection between these two components are to be established. Okay, so now let's take one of the common connection, that is the fixed base plate. Now the fixed base plate, I have already created some of the connections, but I'll show you how to create the fixed base plate. Okay, so for this, I need to first select the node where I need to establish the base plate job and where the base plate are to be designed. So first select that node, and you can go to the smart connection, because in the smart connection you will get the option to optimize it, although the base plate option is also there in the basic connection, but this time I will choose the smart connection. Select the code you need. If you go down, you can see here the base plate. Now you can see different format of the type of the base plate, like pin base plate, fixed, uniaxial, biaxial. So in this case, I'll choose the fixed biaxial base plate. You can see this is the fixed support. So this base plate would be relevant for this support. So selecting this, click on OK. Now here you can see the status. First of all, it will show you that whether the selected template for the existing connection, whether it's compatible or not. If it is compatible, then only it can assign. You can see the status here that it has been successfully assigned, and then it will show you the status that whether it's been designed or not. So in this case, I can see it's not designed. So just click on this, the base plate, the connection that we have just created, and it will take you to this window. This window belongs to the RAM connection. We call it the connection pad. Now here you can find different option to customize the design of the base plate. First of all, you can see all the loading information that are imported from StatPro. If you want to change those values, you can just go there and override those values. So I'm just skipping as it is. And also you can choose the code. Now here you have the option to optimize your design. There are a lot of different options to select to optimize your entire connection operation. Now this is the member. There's the tapered section. That's the reason I am creating this content because for the PEB structure, the pre-engineered building structure, mostly we come across the tapered section. So this is the tapered section, and the good news is RAM connection can handle the base plate connection for the tapered section as well. So this is the tapered section. If you want to replace this tapered section with some uniform section, just like the prismatic section, you can choose the prismatic member. But here I am just keeping the tapered section as it is. And then you have some other options like, okay, the plate shape is rectangular or circular, and so on. So this time I'm just skipping most of the things as the default. Uh, Also, you can control the connection format of the anchor because the anchor is the most vital part in the base plate design. You can define different default settings and you can change those settings like the shape of the anchor, the top portion of the anchor, whether it's having the shape like a J-shaped anchor or the regular anchor, and few more dimension and sizing. You can do it from here. And also one more important thing to just show here, yes, the concrete code because this is resting on the pedestal, right? It is a concrete pedestal. So you can also define the respective concrete code which would be taken by the program for checking the sufficiency of the concrete strength, and it will check the integrity of the base plate with the with the existing concrete. Okay, so from here we can just go to the optimize, or you can directly run the program from here. For example, I'm just running the optimize. It will just optimize the entire design criteria and provide you the most optimum base plate design information. Okay, now the next connection that we will discuss is a very important connection which mostly exists in the pre-engineered building. That is the moment and plate knee. Okay, so next type of connection that we will see is the moment and plate knee. This connection is mostly used for the sections like this beam and column. If we show you the rendered view, it's like this. Now, in the conventional way, you can define the normal beam column flange connection for any roll section, but as it's a sloped kind of beam and also these are tapered sections, so the connection is not like a regular connection. It is to be performed by some specific connection template, which is known as the moment and plate knee. So we have already created this connection. Just to show you how to select that, all you need to do is select the both the members like this and go there and you select this moment and plate knee, MEP knee BCF. So this is the one that we have already created. So if you double click on this, here you can see this MEP knee BCF. Here you can define a lot of information. For example, whether the opposite end is connected or if there exists any opposite end. For example, this member is at the center of two sloped beams. Then you can select this one. In this case, I'm just unchecking this. Now here we have the stiffener. You can just include or you can remove the stiffener, include the full depth. And also we have, let me see which we can show. Yes, there is something called perpendicular to the beam. You can control this alignment. For example, you have made the alignment like this, then the flange or where both the members are being connected will be on the horizontal plane. So if you do it like vertical alignment like this, it will be completely vertical, but in most of the scenario, it's like perpendicular to the beam. Okay, so here you can see this ratio value is reported in red color because there is some issues with the strength check. Go to the result. So here you can see all the design calculations and all are reported. Now, please note one important uh, information here. For example, you can see this representation of this value by some color. For example, if it is green, then you can consider it as a passed. If it is red, then it's failed. But also you might have come across to a color somewhat like yellow, kind of creamish yellow. That is not exactly failed and not exactly passed. You can say it on the favor of pass, but this is not exactly failed. The reason being, this would only be reported in red color if it is failed in the strength limit state. Now, while program design this connection, first of all, it checks some of the key geometric consideration, and then it will enter the design check. Design means the strength check, strength limit state check. Now, before it moves into the geometrical consideration to just check few of the standard geometrical requirement, if few of the geometrical requirements are not met, that doesn't mean that your structure has lost its integrity, it is going to fail, it is going to collapse. That means some of the geometrical requirement are not met, but if your design is passed, the strength check is passed, then program would report this ratio in yellow color. But if it is like, okay, this uh, geometric consideration is passed, but the design check is failed, then it will report you in red color. And if both of them are having some issues, then also it will report you in red color, and it will report only in the green color if the geometric as well as the strength limit state are good in this design check. Okay, let's see another template. Now, this template is also very important, that is at the apex where both the opposite slopes are meeting. To select this, all you need to do, go to this basic connection, and if you go down, there is something called moment and plate BS apex. Now this represents the junction or the point where both the opposite slopes are meeting. So you can select it. So I have already designed it, so I'm launching this from here. So this is the one. Now please remember this, all the sections that we have considered for this design are the tapered sections. So you can see here, these are all the tapered sections. Now here you can change the direction, sorry, change the alignment or change the inclination by defining the vertical angle. By default, it is taking the actual inclination which it has imported from STAD geometrical arrangement. So you have something like flush or extended both way. Also, you can add the stiffener. Let's see. Okay, so this is how it looks, and you can optimize and see the result. Now, I will take a separate session where I will create a content where I'll discuss more on the design steps, design workflow, discuss on the reporting of the design. But in this case, I will only touch upon to just to show you a few of the connection that could be used for the connection of the pre-engineered building. Now, there's another kind of connection that is when both the members are aligned as a collinear member, but you need to establish some connection in between. So for example, here, moment end plate BS, that is the beam splice. Okay, now you might have noticed that initially I could not design it, but later on I need to make some changes in the assignment, and I have added some information, and immediately program could identify and qualify this connection as a compatible one, and it could perform the design. What I've done is, let me show you. First, select both the members, select the beam tool, and here you can see something called attribute. Click on add attribute, go to this member type, and you select the primary beam. The reason being, a program has to consider those member as a candidate for beam only if it is within certain range of inclination angle. In general, it's within 15 degree, but if it is more than that, for example 45 degree or 60 degrees, then program can't identify it as a right candidate to call it as a beam. So that's the reason we need to come here and define and tag this beam as attribute value of primary beam, so that program can identify the sloped member as the candidate for beam. So that is all I have done. And the same practice goes for designing these beam column flange as well as for the apex. So I have already done that before. So in case you are unable to design, even though it is seemingly compatible, then you need to just check if the inclination is good enough. If it is so, then come to this tool and assign those member as a beam, and then you could easily succeed in performing the connection design. So let's see this one. Okay, this is the one that we have recently designed. So this is the arm. It looks like an arm. That's basically the slope beam, and it is tapered, okay, and connected through two flanges. Now here you can also change a lot of design criterias. From here you can select the connector types, and you can define and change few of the dimension and sizes. If you want to include the beam stiffener like this, you can also get it like this at the bottom. So this is a beam splice connection joint. So you can also get the DXF view from here, where it will show you the complete representation of the connection details and its layout. You can directly export it to DXF file from where you can open it in any drafting software like AutoCAD, MicroStation, where you can also add some information or give some final touch to this existing design layout. Okay, so this is all I have to show you for a simple pre-engineered building structure where you can use the RAM connection to design few of the most important connection types, which is very much relevant to this kind of pre-engineered building structure. So hope you have found this session quite informative, and please post your comment, and I will try my best to come up with some detailed video where I will talk more on the design criteria. Then after designing, I will just discuss on the design report and all. This video is not for discussing on the design, but just to show you the templates that are available in RAM connection, which you can use it for pre-engineered building connection design. So see you soon. Thank you.